So there is a topic about how large language models are trained. Okay, so based on what you can see in here, large language models are actually massive probability machines. So as you can see in here, the myth is that LLMs actually store. Many people don't know what LLMs actually, how actually LLMs work. So LLMs do not store exact storage knowledge. They do not retrieve facts like a database. Like you know how it happens within a database when the knowledge is stored, you are going to retrieve based on queries, right? That's not what happens when it comes to an LLM. They do not understand or reason perfectly. They are probabilistic engines. They're completely based on statistical analysis. So what actually happens is that they are massive statistical engines. They're completely based on probability where it is scaled based on 0 to 100%. Like the tokens in the sense, the individual blocks of units within a sentence. Each and every word, each and every token is predicted based on the probabilistic estimations, based on the input which is given, input which is asked to the LLMs. So, whatever language it may be, whether it may be English or Telugu or Hindi, the LLM, the large language models, learn the patterns in the language and they predict statistically likely sequences. So, in the form of sequences, one on one. Just a minute. Can you please turn off your mic, Miss Meghana? Okay. So, we'll get to know about how it actually works within an LLM. So there are four phases which are defined in a unique way. The raw material, which would be the data, the engine room, which will be the processing, the forging process, which is the training and the learning phase, the polish and shipping, which is the refinement and the production phase. Okay, so within the first phase, the first thing which an LLM requires, where if you want to build an LLM, is that data. So data will be collected from various sources like data lakes, online social media accounts, raw data from there, from websites, from digital libraries, from surveys, etc. And all the data will be corrected, which is going to be a massive amount of raw data. It will be cleaned and prepared to have the quality of the data and for the data to be in a particular format which is designed for that particular LLM. So the amount of data would be in large amounts of data, which is in petabytes. Okay, that will be the first step, which is completely about the data, collecting, cleaning, and processing the data. And the second phase is the engine room. Here comes the architecture of the core blueprint of the large language model, where which is completely based on neural networks. Okay, neural networks are multiple layers of neurons, which is inspired by the living brain, where the neurons are interconnected to each other. Right? In the same way, neural networks work in the same way, where there are multiple neurons in multiple layers. Okay, so when it comes to a large language model, the main concept which works behind it is the neural networks and the natural language processing. And the phase three, which is the forging process. This is a computationally heavy phase where the training happens. And when it comes to the training, it depends on the large language model, on the types of training methods which will be implemented. And the phase four, where it will be refined. Okay. So what actually happens is that when we train the model on large amounts of data, it will be generalized model. So refining the raw intelligence means that based on the utility which we have. Like for suppose I'm going to give an example. Like for suppose you have ChatGPT and ChatGPT or any other open source model like Mistral. If you want to have it towards a particular domain, like if you want to have the LLM only towards medical field or towards tech field, you are going to process it. You are going to fine tune it. So it works similarly to that, where we are going to refine the raw intelligence into a usable, safe product. Now we will get to know into more details about the first phase, which is the data collection and processing. Okay. So as I have mentioned before, there are various formats of data which will be collected, like web, books, surveys, code, websites, social media, etc. And they might be copies of the same data. The same data would have been uh, duplicates. There would be duplicates of the data, right? So there will be the deduplication phase where the duplicates will be removed, and the toxic or spam removal phase where we are going to remove the toxic comments like any curse words or any negative comments or etc. Formatting normalization where we are going to convert all the data into a particular format and normalize it into a specific range. And we are going to get the final training data, which is going to be of the highest quality. Okay, next is the tokenization. Tokenization means that we are going to divide the sentence which we are going to have, like ChatGPT Smart, into which is broken down into small components which are called as tokens. Chat GPT is smart. These are individual tokens. For suppose if we have Chat GPT is smart, full stop. The full stop will also become a particular separate token. And actually, these type of punctuations, these special symbols will actually be removed when it comes to after the tokenization, as they are not useful when trying. So these special symbols or repetitive words, there is a lot of process behind it, where we have multiple types of techniques based on the type of technique which we use. The type of processing which we do on the tokens will be different. Okay. And the other point is that, as you know, a machine cannot understand humans' language. It works on binary numbers, zeros and ones. It can only understand zeros and ones. So all the data which we have in the in the categorical format, that will be converted into numerical arrays, as the machine cannot understand human letters. Okay, and these numerical arrays most likely we are going to convert it in the form of vectors. Next, we are going to know about the architecture, the core brain within the LLM, which is going to make everything work. Okay. As you can see in the image, within the slide, below is the embedding layer where the tokens will be converted into numerical vectors. And next, we have the multi-headed attention, where it is a type of attention mechanism where it is going to focus more on the more important aspects. And we have the feed forward layers. Feed forward layers is a type of neural network architecture where we are going to have multiple layers of neural networks, and it goes and the processing happens as it goes forward from one neural network to another neural network. And there is another thing which I want to make you know is that each and every neural network is made up of neurons, which is going to have an activation function. And based on the different types of activation functions, they get activated and go forward with the next layers. The type of processing, the type of activation functions which we are going to select is dependent on the type of problem or the type of architecture which we are trying to build. Okay. And at the end, we are going to have the layer normalization where we are going to have it set towards a particular range where we are going to have it normalized. Self-attention. Self-attention is a type of attention mechanism. As I mentioned before, attention mechanism means that, like for suppose you are in a large crowd, like if you went to a shopping mall with your friend and you are trying to find your friend within a large crowd of people, you are going to focus, right? In the same way, attention mechanism works. Attention mechanism means that we are going to focus on particular aspects of the sentence or the sequences. Okay, like here, where the animal didn't cross the street because it was tired. The more important words, the words which we need to give more importance to are animal and the street, right? As you know, they are subjects, so we are going to give more importance to these type of words which we need to focus more on, and they are going to have higher weights. Weights in the sense, a weight is equivalent to the amount of importance which we are going to give to that particular token. Okay, so weight is a concept where which represents importance when it comes to artificial intelligence. Okay, and self-attention means that where we are going to have the attention within that particular sequence itself. There are mainly two different types of attentions: self-attention and cross-attention. Cross-attention where we are going to compare the attention between one sequence to another sequence, and self-attention where we are going to have the analysis where we are going to have the comparison within that particular sequence itself. Okay, and calculus relationship appears dynamically. Okay, and it is so that we are going to focus on the relevant words, more important words, which we are going to give the more weightage to. See, the reason why we are going to have the attention canon is that in the previous architectures, where each and every token within the sequence is given the same importance, uh, uh, when there is a large amount of data, the model tends to forget the previous data. That's what usually happen. But when it comes to self-attention, we would, because of attention mechanism, we are going to have a global context due to which the model doesn't forget even if it's a large amount of data, the model doesn't forget the context. So attention mechanism has improved a lot of things when it comes to transformer architectures, which started the phase of large language models. This everything when it comes to attention mechanism is started due to attention is all you need. A research paper which has been released a few years ago, a decade ago. Forward pass. So we got to know previously about the feed forward neural networks, right? So it's a method which is similar to that, where where it goes forward for the analysis of the particular sequence. For suppose, let's take this example, the capital of France is, and there are going to be multiple options for that, where the large language model needs to select, and based on the probability distributions of the tokens, it is going to select the most probable way. Okay, this is the core task of the pre-training is the next token prediction. The reason for it is because when the LLM is generating the text, it should predict the next from next word to the next word, right? So that's the reason the core task which is considered is the next token prediction of the tokens from one token to a sequence of tokens. This all happens based on mathematical statistical analysis. Okay, based on this itself, it learns the implicit facts, grammar, and reasoning patterns purely based on statistical prediction, completely based on probability. Feedback loop. Okay, so these large language models, when we are pre-training them, they need to have a feedback loop, right? The feedback loop is so that they can understand the mistakes which they are doing. For suppose, after the engine predicts there is going to be a loss function. It's a function which is going to calculate whether the predicted word is accurate or not. There are various different types of metrics which we can use, and cross entropy is one of the metrics. Loss calculation means that it is going to calculate how accurate the word is, and based on that, uh, through the utilization of backpropagation. Backpropagation means that for suppose, when a threshold is met, where the model didn't predict the next token properly, then using backpropagation goes to the previous step, and there the optimization happens. Optimization means that uh, It is going to make sure that the architecture, the weights which are given to the tokens will be redistributed so that the model can predict even better than before. Here we can see the line. Optimizers calculate how much to adjust millions of internal weights to improve the next prediction. This is for for improvement of the next predictions. And there are various different types of optimization techniques where Adam and Adam W are one of the few. The paradigm shift, pre-training versus fine-tuning. So you got to know what is the meaning of pre-training, right? So you need to know what is the meaning of fine-tuning too. It is these two are one of the most important terms when it comes to large language models. Okay, you might have heard about pre-trained models. So the Mistral or Quen, etc. All these different types of models are pre-trained models, the models which are already trained. Fine-tuning means that we are going to take the pre-trained models and we are going to adjust these models based on our requirements. Like for suppose, as I have mentioned before, for suppose we have a Mistral model and we are going to require it to be fixed to a particular domain. Like for suppose archaeology, so that it gives only information regarding the archaeology subject. So we are going to make it, we are going to fine tune it, we are going to refine it, we are going to customize it such that it is specified to that particular domain. The goal pre-training, the goal of pre-training is predicting the next word, fine tuning following the human instructions, the instructions which we give, that is fine tuning. Retraining, petabytes of chat, chaotic raw web text. It contains a lot of text which these pre-trained models are actually very generalized, which can give information regarding anything because they are trained over that much amount of data without any fixation of a particular topic or a particular domain. Fine tuning means that we are going to give a curated, human curated examples to have it customized over our own, our requirements, which can be a domain or which can be any other requirement. The output. When it comes to pre-training model, we are going to get the output where it cannot be controlled and statistically likely completion. Like for suppose Mm, it's just let's consider a scenario where you are going to ask anything and it can actually give answer to anything without having any restriction over any particular domain. But when it comes to fine tuning answer, when we fine tune a model, after when we fine tune a pre-trained model, it is going to give a formatted answer based on by following the instructions with which we fine tune the model. Okay. Retraining builds the raw cognitive engine, fine-tuning teaches its manners and utility. It manners and utility. Okay. Now the polish, alignment through human feedback. Generation. The model generates multiple distinct responses to a prompt. So the polish here means that the model which has been pre-trained, it needs to be polished, right? So that to see how it works and so that the output which it is giving is of high quality. So what we are actually going to do is this is the loop which is used so that the model can be polished, so that it can be refined, so that it can be enhanced, so that its quality and its performance is increased. So the model is going to generate multiple distinct responses to a particular prompt. The human is going to rank the responses from the best to the worst. Reward model. Reward model where we are going to give the rewards based on the best to the worst case rankings where the human labeled it. And reward model automatically scores the outputs to optimize the final behavior. So that the behavior of the model is optimized based on the reward model. So this is the phase where we are going to refine the model. Evaluation. There are various different types of metrics which we are going to use for the evaluation of a model. The main metrics are these, which are capability, safety, bias, and fairness. Capability means the performance of the model, where there are multiple different types of academic benchmarks like MMLU. Safety, to see whether the model is safe or not, whether the responses which it is giving is safe. which doesn't have any toxicity. Okay, so we are going to check we are going to check the vulnerability test so that there are no harmful responses given by the model, generated by the model. Bias and fairness. Bias and fairness means that to see whether the model is biased to a particular concept, where there may be ethnic group, etc., so that it doesn't have any prejudices. The reason for it is because, the model can actually learn. For suppose there are some people who are fighting over religion, and that a particular text is fed to the model, and it has actually been trained on it. And for suppose because of that, the model can be biased towards particular religions and stuff, right? The reason why we need to have this bias and fairness check is because of that, so that we can mitigate these type of prejudices which are caused due to the data which it has been trained on, which the model has been trained on. Production inference. Now, after the engine is fixed, after it has been evaluated properly, it will be fixed. The fix means that the training of the model is stopped. So no matter how many times we are going to prompt it, the model is not going to learn anymore. The model's weights will be fixed so that it doesn't change based on the user prompts anymore, so that it can be uh, produced for the public use. Okay, this is where the internal parameters are logged. You can understand based on this. If you have got to know about the models, like if you have used models like Quen or Mistral or DeepSeek or any other model, you might have known about 2.7b or 7b or 8b. That means that those are billions of parameters. When it comes to 3b, it means 3 billion parameters. When it comes to 8b, it means 8 billion parameters. It means that those many parameters are within that model which are going to do the computations for the generation of the text. This particular setting where the model's weights are fixed is called as inference mode. Okay, where it is going to work in real time without having any learning, and is going to give responses based on what knowledge it already has. The reality check, risks and limitations. The myths. Many think that LLMs actually have perfect memory or factual retrieval or a flawless logical reasoning. It doesn't have anything of that. It doesn't have any logic. It is completely based on statistical predictions. Okay, it is completely based on statistics, probability, hallucinations. Hallucination is an important term when it comes to large language models. Hallucination means that the model confidently states uh, a generated output saying that it's actually true, but it's actually not true. The model can make errors, right? Those errors are called as hallucinations. The reason why we call them hallucinations is because it calculates based on probability, not facts, not true memory. It forgets past sessions unless the text is explicitly refed. Like when it comes to ChatGPT, if you know, I know that currently there is where we can see that even if we open a new chat window, there is a connection between one chat to another chat when it comes to ChatGPT. Right? But previously, it wasn't like that. Like based on the context window it has, it is going to have the information. Like for suppose, if a model has only 1 million context window, it means that 1 million tokens. If it has only that much context window, no matter how much how much information, new information which we feed it wouldn't be able to understand. I mean, it wouldn't be able to save that particular knowledge within it. It all depends on the context window of the LLM which we are using. Brittle reasoning. It perfectly mimics human reasoning patterns. Okay, it mimics patterns. It doesn't have any logical understanding because it is completely based on statistical predictions, based on probability. Okay, now let's go with the what we have learned again. The first one is raw fuel, which is the data. where the data will be collected and processed. Next is a forge, where we are going to have the architecture built, where the pre-training happens. Next is a polish, where based on the reward model, it will be enhanced. And here also we are also going to have the metrics like bias and awareness check, performance, etc., and the deployment. After the model has good performance, the weights will be locked so that it doesn't train anymore and is going to be in an inference mode. Okay.